Hello friends, I am Mangesh Joshi. Today I will be teaching you the subject that is engineering drawing. The first topic of our subject is orthographic projection. Now first of all we have to understand what is ortho. So the basic meaning of ortho is perpendicular. So it is nothing but a perpendicular projections. Now what do you understand by the term projection? Now as you have heard that a projector is there. So what is the purpose of a projector? So projector basically projects the light or image on the surface. Okay. So that's why the projection is getting image of an object. That is a perpendicular image of any object. For example, if you draw a vertical surface representing a wall, okay, and if you draw a horizontal surface perpendicular to this, so this represents the ground. So we will write it over here, that is ground. Okay. The angle between the wall and the ground is 90 degrees. So if you place an object between this wall, so let us take an object as a cylinder. If you place a cylinder between the wall and an observer, so you have an observer, that is this. So this is an observer. Okay. Now if you throw a light from this observer to this object, you will get some shadow on this vertical wall surface. For example, if you throw a shadow, so this shadow will be seen as a rectangle. So this shadow is called as a view. So this is called as a view. Okay. Now again, if you throw a light from top direction, so its image will be obtained on the ground surface, which will be a circle. So this is the projection of this. So this shadow is called as the view. So till now we have seen various terms. One is wall surface, other is ground, then this one is object, and this is the observer, then this is a view, this is second view. Now since the observer is observing from this direction, that is the front direction, we will name this view or shadow as a front view, because you are getting an image from the front direction. So naturally this view will be termed as top view, because you are getting an image when you are observing from the top direction. That's why this view is called as top view. To accommodate these two views on a sheet of paper, what you require? The requirement is you have to rotate this ground over here. Now this wall surface is termed as vertical plane, because the wall is vertical. So this, in technical terms, this wall is termed as a vertical plane, indicated by VP. Similarly, this ground surface is indicated by HP, representing horizontal surface. Now if you rotate HP on this side, what you will get? You will get two planes. So the upper plane is called as vertical plane and lower one is called as horizontal plane. So I am naming this over here. So this is a vertical plane indicated by VP, and this is a horizontal plane indicated by HP. So the line joining this vertical plane as well as horizontal plane will be termed as XY. That is the datum line or reference line of these two planes. Now if you want to locate the position of the object, so how this object is located? It is some distance above this ground or horizontal surface. This object is some distance above this horizontal surface. Let us take this distance as 30, and it is some distance in front of the vertical plane. Okay. So let us take this distance as 20. So in first quadrant method, how this object will be located? It is 30 mm above horizontal plane and it is 20 mm in front of vertical plane. So this was the introduction to orthographic projection. So now we will start with the projection of point and projection of lines. So first we will see the projection of point. For this we will again require the horizontal plane and the vertical plane. So as I have already told you that this is a XY line, that is a reference line. This is vertical wall surface is called as vertical plane. Horizontal wall surface is called as horizontal plane. Now projection of a point means you are obtaining an image of a point or shadow of a point on this vertical plane as well as horizontal plane. So if you consider a point A, if you consider a point A situated at, say, let us take this distance as 30, and this distance as 20. So if you want to tell the location of a point A, so this location of a point A is 30 mm above horizontal plane and 20 mm in front of vertical plane. Now you have to obtain a projection. So you have to obtain the projection of a point A. As I have already told you that the projection of a point A means you have to draw the shadow of a point A or image of point A or front view and top view of point A. So if you observe this point from this direction, here is the observer. So if you observe this point A from front direction, it will be seen as, again it will be seen as a point. So this point will be called as A dash. Similarly, if you throw a light or observe this point A from top direction, so its image will appear on horizontal plane. So this image of point A will be termed by small a. This is the naming convention that you have to use for obtaining the projection of point on vertical plane and horizontal plane. If you are observing from front direction, so you will name this point as a dash. Simply you have to put a dash. And if you are observing from top direction, so simply you will use a small letter, that is a. So the meaning of orthographic projection is, now this red lines is nothing but a projection, or this is called as a projector. Similarly, this line is called as a projector, which helps you to obtain the image. Now the orthographic projection term. So what is that? It is perpendicular projection. So these projectors will be perpendicular to vertical plane as well as the horizontal plane. You can see here that this projection is perpendicular to vertical plane and this projector is perpendicular to horizontal plane. So this is the orthographic projection of a point. Now this projection is in the 3 dimension, that is, so you have to bring this projection of shadows on one paper, as we have discussed over here already. So you have a vertical plane over here. So you want to locate the projection of a point. So this distance we have already taken as 30 and this distance we have already taken as 20. So if you observe from front direction, so it is 30 mm above horizontal plane. So how will you locate this in a sheet? So you will be drawing a horizontal line representing this height of 30 mm. So this distance is nothing but a 30, which is seen in vertical plane. And similarly, since this distance is 20, therefore this distance will also be 20 because these lines are parallel. So that's why we will draw this 20 distance in top view. So this is that 20 mm distance. So this first vertical line is representing the A dash point and this 20 distance is representing the A point. Now next is what this distance is called as. This distance is called as height of point A dash, represented by HA, that is height of A dash. Similarly, this distance is called as in front of vertical plane. That this distance is called as in front of vertical plane distance. That is, this point will be rotated over here. Similarly, this distance will be rotated over here. So this in front of VP distance will become the depth here. So one is termed as height of A point, other will be termed as depth of that point. Okay. Now we have to locate actual location of A dash and A point. So as you can observe over here that A dash here and here. So this is parallel to this line. This is parallel to this line. So if you rotate this point on this here, so ultimately you will get A dash and A on a straight vertical line. So I am simply drawing a vertical line representing the projectors of A dash and A. So the point where it cuts horizontal line, that is horizontal height of that point. So this will be point A dash, and it is cutting horizontal line, that is depth. So this point will be termed as A. So this A dash will be termed as a front view of a point A, and this A will be termed as top view of the same point A. So we will once again revise which we have covered till now. So again we have started with orthographic projection. Ortho means perpendicular, projection means to display an image. So here we have seen the image of point A. So if you obtain the image from front direction, this A dash will be termed as the front view of point. If you observe this from top direction, so this the image of this point A is termed as top view of a point. So if you want to draw this on a same sheet of paper in one plane, so that we have done over here. First we have drawn the horizontal line representing the height of point A, which is 30 mm. Then we have drawn again second horizontal line representing the depth of point A, which is nothing but in front of vertical plane distance. And to locate A dash and A, what we have done, this we have drawn one vertical projector of point A. So this intersection of horizontal line and vertical line giving you A dash, and intersection of horizontal line and vertical line giving you the top view, that is A point. So in this way we have obtained the image or shadow or view of point A. So next is the projection of a line. So we have started with a point. If you extend the same point, if you stretch that point, you will get a line. So next we will be seeing projection of a line. Projection of a line. Let us name this line as line AB. Again we will be drawing the same diagram which we have just drawn. This is a vertical plane and this is a horizontal plane. So let us name these two as, this is vertical plane and this one is horizontal plane. So now we have to obtain a projection of a line. So let us take a line. So in this there are basically different types of positions which can be obtained in the projection of a line. So first is a line AB is parallel to horizontal plane. So what is the first position? The line AB is parallel to horizontal plane. So since a line is parallel to horizontal plane, so we have to draw a line which is parallel to horizontal plane. So let us name So I am naming a line which is parallel to horizontal plane and perpendicular to vertical plane and perpendicular to vertical plane. Now the location of a line, let us assume this whiteboard as a vertical plane and this surface is called as horizontal plane. So location of a line is like this, which is parallel to horizontal plane and it is perpendicular to vertical plane. So if you observe from front direction, let us take this as an observer. If you observe this line from front direction, what you will see? You will simply see a single point. So it can be termed as A dash as well as B dash. So if you obtain the projection of this, observer is over here. So this projection of this line AB will be seen in front view. So this is the image or shadow or view of object or of a line in on vertical plane. So this point can be termed as A dash and B dash because it is from the front direction. So similarly, if you observe the same line from top direction, so what you will see, so this line will be, so this A point will be projected over here, this B point will be projected over here. So ultimately you will get a projection like this. So we will project this point, B point on top direction, A point over here. You are observing from here, top direction. So this shadow of point A in top direction, you will name this as A point. Similarly, shadow of B in top view, this will be named by small letter B. And if you join this AB, it will give you the top view of line AB. And similarly, this A dash B dash is giving you the front view of a line AB. Now again you have to draw this on a sheet of a paper. So again I am drawing the square. This is the XY line, reference line. So where is the XY line in this? So joining this and this. So this is representing the reference line or XY line. So I have drawn XY line. So this is vertical plane. This is horizontal plane. Okay. Now you have drawn A dash B dash as a single point. So first we will draw a vertical line representing the projectors, a vertical projector of A. So let us assume that this line AB is 40 mm above horizontal plane. Means if this is an horizontal plane, so this line is 40 mm above this horizontal plane, and this point A is 10 mm in front of vertical plane. So this point A is 10 mm in front of vertical plane, and this line is 40 mm above horizontal plane. This is the location of a line. So first you have to draw a horizontal line representing the height of the line. So height is 40. So I am drawing one horizontal line representing the height. So this is 40 mm. And the depth of point A is 10 mm. So I am drawing the second line representing the depth of point A. So this is height of line AB and this is depth of A. It is 10 mm. So now we have to locate the line. So which points will be given? Namings, this point will be A dash as well as B dash, because the projection of a line is only a single point. So this point is termed as A dash and B dash because it is a point of front view. And this point will be termed as A because the depth of A is 10 mm. But how to locate the point B in top view? So for this you will require the length of the line AB, that is actual length of the line AB. Let us take that the length of this pane as 80, or representing a line, it is 80 mm length. So this length of the line is 80. So how to locate point B? So how to calculate the depth of point B? You already know that A is 10 mm away from VP. So 10 mm, A is 10 mm in front of vertical plane. So and total length of the line is 80 mm. So what will be the total length of point B? So this is total 90 mm away from vertical plane. So you can mark point B 90 mm from this reference line, that is here. So distance of A to B will become 80 mm. So the distance of A to B representing the top view. So here A to B is this distance. So this will be termed as top view of the line AB. And similarly, this A dash will be termed as front view of a line AB. So our next position of a line is a line. This will be parallel to vertical plane and perpendicular to horizontal plane. So let us see what difference it makes. So what is the position? So now line AB is parallel to vertical plane and it is perpendicular to horizontal plane. So now we have to draw the shadow or view of a line. So now let us consider this as a vertical plane and this as a horizontal plane. The location of a line is parallel to vertical plane. So now the line is parallel to vertical plane and it is perpendicular to this horizontal plane. Now we will skip the drawing of HP and VP. Now we have to start imagining the location of line. So now it is parallel to vertical plane and it is perpendicular to horizontal plane. Again, let us take the length of the line as 80 mm. So your first assumption is the original length of the line or true length of the line. True length or original length. Is given to be 80 mm. So this true length is represented by the term TL, true length. It is equal to 80. And height of point A is given as it is 10 mm above horizontal plane. So how will you name that? So I will name height of point A as height of a point A is equal to 20 mm. So it is represented by HA, and since it is height, we will put a dash for front view. So it is 20 mm. Now we have to draw the projection of a line AB, which is parallel to vertical plane and perpendicular to horizontal plane. So with this data, we will be drawing the projection. So what is the first step? First step is to draw a reference line. Reference line XY. Now we will not draw the squares which you have already drawn. Now we will only require the reference line, which will be called as XY line. Next, so height of A dash is given to you, that is 20 mm. And the true length of line AB is given as 80 mm. And let us assume that this line is 40 mm in front of vertical plane. So this in front of distance is termed as a depth in this case. So what you will do, depth of line AB is equal to say 40 mm. So we have two data, that is three data: HA dash, true length of the line, depth of AB, and you have to draw projections. So drawing projections means you have to draw front view and top view. So you have to draw front view as well as the top view. So let us imagine the case. So if you observe this from front direction, so in this case observer is over here. So observer is observing the line AB from front direction. So this point A is 20 mm above the horizontal plane. So let us draw first the location or height of point A. This is representing the height of point A, that is A dash. It is 20. So we have now first located the point A dash. Then, as you know that the length of the line is 80 mm. So naturally this is parallel to vertical plane. So you will observe this entire length of 80 because it is parallel to vertical plane. So this is the location of point A. So where will be B located? It will be total 20 mm plus 80 mm above horizontal plane. So naturally after this you have to locate B dash point. So height of B dash is nothing but this distance plus 2 length line distance. So total will be 100. This to this distance is 80. Now what you have to imagine, what will be the top view of this line? So top view of the line will be seen as a single point. If you obtain a shadow on here, so that A point and B point will overlap. So that's why it will be seen as a single point. So you simply have to draw a projector. This is a projector. So intersection of this projector over here will give you the point B dash. Similarly, intersection of this here, it will give you line point A dash. And as you know that this line is, depth of line is 40 mm. So I will be drawing a horizontal line representing the depth of a line AB, which is 40. So again, intersection of this vertical projector and horizontal projection gives you the top view of a line AB. So this will be indicated by A comma B. Sorry, then this will not be A comma B, this will be B comma A. What is the difference between A comma B and B comma B? If you are observing from top direction, so the point B dash appears first. So that's why we will name B as first, then A, because A is below B dash. So that's why in top view what convention we have used? We have used B comma A. So this is the projection of a line which is parallel to VP and perpendicular to HP. The third case is a line AB parallel to HP as well as vertical plane. So this line AB is parallel to HP and VP both. So again you have to imagine that how this situation can be. A line is parallel to horizontal plane also and parallel to vertical plane also. So this is the position of a line which is parallel to vertical plane and parallel to horizontal plane. So let us assume that this line is say 40 mm above this horizontal plane. So how this above distance can be indicated? It can be indicated as h of A dash B dash, that is height of A dash B dash is equal, or you can write it down like height of A dash is equal to height of B dash is equal to 40 mm. Why it is parallel? Because both the heights are same. Height of point A from horizontal plane, similarly height of point B from horizontal plane is 40. So that's why I have written over here is 40. Similarly, just assume that depth of point A is equal to depth of point B. Let us take this as 30 mm. Means point A is 30 mm in front of VP. Similarly, point B is 30 mm in front of VP, making this line AB parallel to VP. So this is given to you. Let us assume the true length of the line AB, again same as AD. And what you have to draw? You have to draw front view and top view. That is the projection of a line. So if you imagine, it is like this. So if you observe from front direction, this point will be focused over here. This point will be focused over here. So ultimately, what you will get, the same 80 mm length in front view. So first we will draw the reference line. Always you have to draw reference line first. So this is reference line XY. Next you will be drawing the heights, that is 40 mm and 30 mm. So height of A dash is 40. So this is height of A dash as well as height of B dash. It is 40. Similarly, you have to draw depths. So depth is 30 mm. So from here, so depth indicating the in front of vertical plane distance. So this is 30. This is depth of A, comma depth of B, indicating the in front of vertical plane distance. Now again you will require a projector to get a projection of a line. So now you will require two projectors, one for A, one for B, because A point is also different, B point is also different. So one projector is this. This is the projector of, let us take A dash, and since this projector and this projector is 80 mm apart, so A dash and B dash, the true length is 80. So this point as well as this point intersection. So you will name this point as A dash and this point as B dash. The true length is 80. So this is the true length, 80 mm. And similarly, the same length will be observed in top view. If this length is 80, so the same length is projected over here because it is parallel. Similarly, if you observe from top direction, the same length will be projected on this plane also, horizontal plane. So you will get the same length, that is this as A and this as B. So again this represents the top view, which is equal to true length. And again this is true length, which is nothing but equal to front view length. Okay. Now this is the projection of a line parallel to both HP and VP. Now if you consider the case of a line perpendicular to both HP and VP, so the answer of this is, it is not possible. A line can only be perpendicular to only one plane, then not to both planes. Just for example, if you take line perpendicular to vertical plane, so it cannot be perpendicular to horizontal plane. Again, if you take case of a line perpendicular to horizontal plane, so it is not possible to that this line will be parallel to vertical plane also. So a line can only be perpendicular to only one plane, but the line can be parallel to both the planes, as just we have seen the example. Now the next is the more difficult case. Now this is not difficult, but right now we are taking it either perpendicular or parallel. Now we will assume a line inclined to this plane or inclined to this plane. So let us take that case. next case is a line inclined to horizontal plane and parallel to vertical plane. Now since this is the first case of inclination, we will draw a three-dimensional diagram, that is HP and VP diagram. So this will be termed as vertical plane, this will be termed as horizontal plane. Now what is our assumption? That a line is inclined to horizontal plane and parallel to vertical plane. So how that line will look like? So a line is inclined to let us take this line as AB. So this is the actual line AB. Again the true length is 80 mm, line of 80 mm length, which is inclined at, let us take this angle as 30 degree. So the line is now inclined at 30 degrees to horizontal plane, and as you can see that it is parallel to vertical plane. So this is the case. Now there are various terms associated with the inclination. So for that, just you note it down that these various terms, as we have already seen, the true length is the original length of a line. Next we have seen that it is 30 degrees inclined to horizontal plane. So this theta, this is the indicated by theta. So this theta is nothing but inclination of a line with horizontal plane. So what is theta? It is inclination of the line with horizontal plane, that is HP. And next term is alpha. So what is alpha? Alpha is inclination of front view. It is inclination of front view with XY line. Can you identify difference between theta and alpha? So theta is actual inclination of a line with horizontal plane. So in this case theta is 30 degree. Actual inclination of the line with the horizontal plane indicated by theta. Now what is alpha? So alpha is inclination of the front view of the line with XY line. So how to get alpha in this case? So for that you have to project this point B on vertical plane. Similarly, you have to project point A on vertical plane. So this image or shadow will be termed as A dash because it is the projection of A dash, and this image of this point B will be termed as B dash, as it is the shadow or image or view of B point. Now if you join this A dash B dash, if you join A dash B dash, it will be the front view, that is the image or shadow or view of a line AB in front direction. So this is termed by A dash and B dash. So this red line is nothing but the front view. But since the line is parallel to vertical plane, the true length of the line will be the same as the front view length. So this is true length is equal to true length. So what is the true length? So true length, which is this, true length is actual length. So it is 80 mm. If you obtain the projection or view of this line on VP, so length of front view will also be 80 because it is parallel, it will not change. So that's why I have written over here that front view is equal to true length, that is length of front view is equal to true length. Now we were discussing about the alpha. So what is the alpha? Alpha is the inclination of front view with XY line. So can you mark the inclination of front view with the XY line? So this inclination is termed as alpha. So again it is written with XY line, so definitely this angle will be equal to this angle if you extend this. So this is alpha. So this alpha and this alpha is same. That's why I have indicated this alpha over here. So in this case, since the line is parallel to vertical plane, your theta is coming equal to alpha because it is the front view length is equal to true length. That's why your theta is equal to alpha. So again alpha, you have found that it is also 30 degree because line is inclined to horizontal plane and parallel to vertical plane. Now if you obtain the projection of this line in top view, what will happen? Let's see. If you see this line from top direction, so the projection of this will be appear over here. The projection of point A, you are obtaining it over here. So I will name this as A. Similarly, if you obtain projection of point B over here, so you will get point this as B. And if you join this A and B, what it will give you? It will give you the top view of a line AB. So now if you measure the length of the top view, that is AB, so you will find that the length of the top view, that is nothing but length from A to B, will be less than the true length. If you measure the length of AB, you will observe that the length of the line, that is 80. So this length of top view or length of this AB will be less than true length. Why it happens? Because when a line is inclined to horizontal plane, it is not parallel. So that's why the projection of this point will appear over here. So this much length will be the top view length and actual length is this. So your top view length will not be equal to the true length because true length is 80. So you will get a reduced length, that is top view length, that is apparent length. So this length of top view is reduced in this case. So if you want to draw the same on a sheet of paper, so how will you draw this? So for that you will require some data. So let us assume a data. So let us assume true length of the line as 80 mm. Then let us assume height of A dash as say 10 mm. That is, this A point is 10 mm above horizontal plane. Let us assume depth of point A as 15 mm. So it is, this distance is 15 mm. Let us assume theta as, let us assume theta as 30 degree. That is this, theta as 30 degree. Now next is you have to draw projection. So that is, you have to draw front view and a top view. So how to draw this? So for that, what you will require first? You will require a XY line. So I am drawing XY line over here. The next step is to draw the horizontal heights. So what you have height of A dash and you have depth of A point. So let us draw this first. So you have this height of A point, then you have depth of A point, now till our exercise, that what you have observed, that the point A and A dash will always will lie on a vertical straight line. That is, this A dash and A will lie on a vertical straight line. If you rotate this plane over here, so I will be drawing a simple vertical line representing the vertical position of point A. So you can draw this line anywhere. So this is just as a starting point for our problem. So this point will be termed as A dash, and since this point is a top view, so this point will be termed as a A. So you have got the starting point of a problem. Now next, you know that this is A dash you have got. Now since theta is equal to alpha, since the theta is equal to alpha, so you will draw a 30-degree line from here representing the front view. That is this, because you have to draw the front view of the line. So the length of this is 80. So from A dash to B dash, this length is 80. So this is the front view and this is the B dash of a point. Now next is you have to mark the location of a point of point B. So since it is parallel, line is parallel to horizontal plane, parallel to vertical plane, so the depth of A will be equal to depth of B. This is the assumption, because it is parallel. So depth of A will be equal to depth of B, which is 15. So as A dash is lying on the straight vertical line of A, similarly B dash. If you draw perpendicular line from B dash, it will intersect over here. So this intersection will give you the point B. So this line will give you the top view, and this is equal to front view is equal to true length, because it is parallel to vertical plane. And if you observe, the true top view length is not equal to true length. Now the length of top view is reduced because it is inclined to horizontal plane. So, and again, this angle is alpha is equal to theta, since it is inclined to horizontal plane. So this theta will be equal to alpha. That's why we have named a front view is equal to true length. So this completes the projection of a line inclined to horizontal plane and parallel to vertical plane. Now we have seen that you have got the front view and top view of the line. So the next is you are having the true length in the front view, but you are not having the true length in top view. So if you want to find out the true length in top view also, so what you have to do? So for that, just listen over here. Now you have this theta over here. So just I am erasing this. So this is theta and this one is alpha. So you know that here is front view is equal to true length. Your objective is to find out the true length in top view also. So one major reason that why the length of the front view is the true length. So it is the major reason is that this line AB is parallel to the vertical plane. So that's why it is showing you the true length. So what you have to do for finding out the top view length is equal to true length. So what you will do, you will basically rotate the line so that such that this line AB will be parallel to this horizontal plane. So how will you rotate this? So that will be shown by this curve. So now you have rotated the actual line. So now it becomes parallel to the horizontal plane as well. So let us name this point as point B1. So this is nothing but the new position of the line AB indicated by B1. So if you obtain the projection of a point B1 on the front plane, so how it will be seen like? So you obtain the projection of a point B1. So this will be projected as it is over here. So as a result, you will get the same point over here as a rotation of front view. So now this point is nothing but the point B1 dash. Again, if you obtain the projection of B1 in top view, so what you will get? You will get one point, the projection over here. So this point will be indicated by point B1. So what you have made, basically you have made the line parallel to horizontal plane and you have obtained the projection in front view as well as top view. So if you observe, the point B1 dash will lie in straight vertical line as B1 also. Just similarly like A dash is below A, sorry, above A. Similarly B dash is above B. So similarly, B1 dash will be above point B1. So if you draw this situation over here in two-dimensional plane, so how will you do this? So for this, you have to rotate the front view so that the line will be parallel to the horizontal plane. So till which point you have to rotate? You have to rotate such that the line is parallel to horizontal plane. So this is the rotation of the front view. So this point I am naming this as B1 dash. So A dash and B1 dash, A dash and B1 dash is that line, which is representing the front view. Similarly, I will project this B1 dash point over here in top view. So you will get point B1 in top view. As this earlier discussed, A dash is above A point. Similarly, B1 dash is above B1 point. So if you measure the distance of A to B1 in top view, so this will be equal to the true length. Why this will give you the true length? Because the line is parallel to HP. A B1 line is parallel to HP. That's why it is giving you the true length in top view. So A to B1 is the true length, whereas A to B is the top view length. So in this way we have found out the true length in top view as well. So what procedure we have followed? We have rotated the front view and not the true length. In this case, front view length was equal to true length. That's why it is seen like you are rotating the true length. But actually what we have done, we have rotated the front view length and then you have projected B1 dash up to this point to get the true length in top view. So one rule is rotate only front view or top view. You will never rotate true lengths. Only front view and top view will be rotated. So in this case, you have find out the true length in top view as well. Let us move on to the next position of a line. That is, this case was a line inclined to HP and parallel to VP. So your next case is line inclined to VP and parallel to HP. So line inclined to vertical plane and parallel to horizontal plane. Exactly reverse of the same. So just to draw this, let us take these two planes. This is VP and this is horizontal plane. Now the line is inclined to vertical plane. So, and parallel to horizontal plane. So now this line, suppose this line is name this as AB. So this line AB is inclined to vertical plane. So as the meaning of this line is inclined to vertical plane. So this is making some angle with the vertical plane, that is wall surface, and it is kept parallel to horizontal plane. So inclination of a line with vertical plane, it is termed by the term phi. In the earlier case, inclination of line with HP was theta, and so in this case, inclination of line with respect to vertical plane is termed as phi dB. And second thing, inclination of a line, of top view of a line, inclination of top view of a line with xy, which is this is called as beta degree, whereas in the earlier case it was alpha degree, inclination of front view with xy. So similarly, this is inclination of top view of a line with xy will be termed as beta. So we have introduced two terms, one is phi and other is beta, remaining other terms as fixed. So let us assume that this line is 45-degree inclined with vertical plane. So I will draw the situation where line is inclined at 45 degrees with vertical plane. So this is the line A and line B. It is parallel to horizontal plane and it is inclined at 5 degrees with the vertical surface. So if you obtain the projection of this line, so what you will get, the projection of this line, so you will project this point on vertical plane, similarly this point on vertical plane. Similarly, you will project this point in top view, this point in top view. So I am projecting this point over here. So you will get the one point as A point, A dash, represented by the front view. Similarly, you will get another point indicated by B dash. So this A dash and B dash represents the front view of the line. So this is the front view of the line AB. Similarly, now the line is parallel to horizontal plane. So that's why we have to project it over here. Now since the line is parallel to horizontal plane, the true length of the line will be same as top view length of the line because it is parallel to horizontal plane. So now this is A point and this is B point, that is top view. So this is top view, which is equal to true length because now the line is parallel to horizontal plane and the projection of A dash will match with this. Again, A dash will be lie on vertical straight line such as A. Similarly, with the case of B, it will be perpendicular to B, and this angle will be beta, inclination of the line with xy line. So since this is the top view, I am naming this angle as beta because it is inclined at beta degree with xy. Similarly, since this is inclination of line, actual inclination, so since actual inclination of the line with vertical plane, so it will be termed as beta. So in this case, beta is equal to phi. That's why your top view length is equal to true length. So let us draw the situation, this situation in two-dimensional. So this is the xy line. So first, let us assume some data. So let us assume that the true length of the line is 80 mm. Then height of A dash is equal to 10 mm. Let us assume the depth of A dash, depth of A is equal to 15 mm. Then let us assume the beta is equal to 45 degree, which is also equal to phi, because the line is parallel to HP. So theta is equal to beta is equal to 45 degree. So you have to resume. So first what you will do, since the position of this A dash is known, so I will first draw a vertical line. Again you can draw this vertical line from here or here. So next I have to mark the positions of A dash and A. So this is the positions of A dash, which is 10 mm above horizontal plane. Let us mark the position of A point, which is 15 mm below the vertical plane, below the HP, sorry, below the XY line. So the intersection of this will be termed as A dash, and this intersection will be termed as A point. So let us draw. You have drawn this and you have drawn this. So next is your beta is or is equal to phi is equal to 45. So this inclination is seen in top direction. So that is, so this will be drawn over here. So always remember, theta and alpha will be drawn above XY line, whereas phi and beta will be drawn below XY line. So since this is phi or beta, so we will draw from A point. So since it is 45 degree, so I am drawing a line of at 45 degree. So this is the length of top view. It is given as it is the true length, not top view, it is true length. So since the true length is equal to top view length, so since the true length is equal to top view length, I am naming this point as B, point B, and this angle is nothing but phi is equal to beta. Phi is equal to beta. So now you have to find out the point B. Again, this line is parallel to HP, means the height of A is equal to height of B, because it is parallel to HP. So this height will be same as this height. So this is nothing but height of B dash is equal to also 10, because the line is parallel. So in order to locate point B dash, what simply you have to do? You have to simply project B a point over above. So that will give you the point B dash. This is the B dash. Okay. Now, which will be the foot of front view length? So if you join this, so this will be front view length, which is not equal to true length. The front view length will be less than the true length, that is less than 80 mm. So the length of top view is equal to length of true length, but this is not equal because it is inclined to vertical plane. Again, next question comes to our mind is how to find the true length in the front view. We have just solved earlier. So what we did in this problem, we made line parallel to the vertical plane, because it is inclined to vertical plane, so we have to make it parallel so that you will observe the true length. So to make the line parallel to vertical plane, what you will do, you will rotate this line over here, so that now this will be parallel to vertical plane. So this is nothing but point B1. Again you will obtain the projection of B1, so it will go over here. So this is the B1 dash point, that is the projection in front view. Similarly, you will project this B1 in top view. So it will go over here and you have to rotate it. So this is the point B1 in top view, and this represents this rotation. That is, you are rotating this. So similarly, if you want to match this condition with here, what you have to do? You have to rotate the top view length and not the true length. So you will rotate this B point keeping A as the center. So we will rotate this much length. It will give you B1 point. So how to find out B1 dash point? It is very simple. You have located B1 point. The projection should match. That is, B1 dash will be above B1 point. So this will be extended up to the position of B. So this point will be termed as B1 dash point. So now if you measure A dash to B1 dash, you will observe that this A dash to B1 dash length is equal to the true length of the line, which is 80 mm. So in this way we have to find out the true length in front view. So again in this case you will be rotating the top view. Rotating the top view. And remember one thing, never rotate true length. Never rotate true length. You will only rotate either front view or top view. You will simply project the true length. So again, one point to remember in this case is, let us assume that now you do not know the top view and you have to find out the top view. So how will you mark that? First you will mark 80 mm, keeping over here and cut an arc of here. So you will get point B1 dash. Then you will project this point up to B1 and then you will rotate. So don't worry right now, we will solve this problem in detail. So just remember, rotate the top view or front view and never rotate true lengths. So this is the case where line is inclined to VP and parallel to HP. Our next case is the line inclined to both the planes, that is HP and VP. Now the problem will become more complex. But only if the basics are clear, no need to worry. Just remember one thing, if you keep line or if you make line parallel to the plane, you will observe the true length. Only this is the concept. So now we have drawn this. This is the case. Earlier we have drawn the line inclined to HP and parallel to VP. So I am drawing the same case over here. That line inclined to HP was there. And it was parallel to VP. And you have rotated this B dash point over here to obtain the position of B1 dash, and then you have projected this over here to get point B1. Now this was the case where line was inclined to HP, that is theta was equal to alpha, and front view length was equal to true length, and top view length was not equal to true length. Now the next case is the line inclined to VP and HP both. So this is the case that your line is inclined to HP and it is also inclined to vertical plane. Means now the line is neither parallel to HP or nor VP. So in this case, how to find out the true length? Because true length will not be seen in any of the views. That is neither front view nor top view. So this condition will be basically the addition of these two. Means here line was inclined to HP. So this is the case where line was inclined to HP. This is the condition which is line inclined to VP. So in this case line inclined to VP. So we have to combine both the conditions to obtain the front view and top view. So in this condition you will not get front view length is equal to length, or you will not get top view length is equal to length. So how to combine this? So our basic principle remains the same. Rule number 1, never rotate true length, only rotate top view or rotate front view. This is rule number 1. Rule number 2, which is the basic rule, if you make a line parallel to any plane, you will observe the true length. Okay. So let us try to combine these two. So for that we will require a problem. So let us take one small problem, that let us assume that height of A dash is equal to 10 mm. Second, depth of A is equal to 15 mm. Then the angles alpha is given to be say 30 degree. Alpha is given to be 30 degree. Let us take this as 40 degree. Then fourth is given as beta. You are given with beta as, let us take beta degree as 55, and you are given with fifth, that is length of front view is equal to, let us take 55, let us take it as 60. So you are given with 5 data, that is height of A dash is 10, depth of A is 15, your alpha, that is inclination of front view of the line with xy. Similarly, beta is inclination of the line, that is inclination of top view with xy. This is inclination of front view with xy. So if you match, this data will be matching, that length of front view is 60 and inclination of front view is 40. So how to proceed for this problem? So now we have to combine both the cases. How to combine this? Let us see. So first you will require an xy line. First you will require xy line. Then you have to mark the locus. Then you have to mark the height of point A. So height of point A is 10 mm. So this is the height of A dash on 10 mm. Similarly, depth of A is 15. So this is depth of A, 15 mm below xy. Then again you have to locate A point. So let us start this point and this point. So let us name this as A dash and this point as A. So once you mark the lengths, the job of lengths are over. Then alpha is the angle of front view with xy line, that is this alpha, angle of front view with xy, which is drawn from A dash. So we have this point, that is the starting point for front view. So you will draw at 40 degree from here, representing the alpha, and In this case, alpha is not equal to theta because line is inclined to both the planes, HP and BP. So after drawing this alpha degree, on alpha degree, what you have to mark? Alpha is the angle of front view. So you have to mark the front view length on this alpha. So this is the front view length. So this point, after marking the front view length, you will get point B dash. So let us name this point as B dash. And always remember the points of front view is A dash B dash if the name of the line is AB. And the point naming of the top view is A and B if the line is AB. Then this is point B dash. You have got the front view. Then next, what you are given with? You are given with beta degree, that is 55. So you can observe over here that beta is drawn from A point, and which you have to mark. This will be marked by top view length. So first let us draw the beta that is on 55 degree from A point. So now I have drawn the beta degree. Now we do not have the top view length with us as like front view length. So what you have to do next is, what you can do, you can simply, as you know that A dash point is above A point. So similarly B dash point will be above B point. So simply project this point or transfer this point on this line. Transfer straight vertically down on this line. So you will get B point. So this is nothing but intersection of beta line and vertical projection. So this will give you the length of the top view. So we have got the B point. So now we have to find out the theta and the phi. So theta is nothing but the true length of the line, that is inclination of true length of the line with horizontal plane. Similarly, what is phi? It is the inclination of true length of the line with vertical plane. So how to find out the theta and phi as well as the true lengths in front view as well as at the top view? So now we will have to combine this approach and this approach. So first let us suppose we have to find out the theta or the true length in front view. So what you will do? So we have to just follow the same steps that we have followed over here. So what we did over here, we have rotated the top view. So I will rotate the top view to give me the point B1. So let us rotate the top view from here. So now I am rotating the top view so that now my top view is parallel to horizontal plane, that is XY. So this is the point B1, similar to this. So how to locate the point B1 dash? The same logic, that A dash will be above A. Similarly, B1 dash will be above B. So in this case, what we did, we have extended the B dash point over here. So similarly, we will extend the B dash point horizontally. So this extension of this is called as the locus of a point. So this is called as locus of point B. The meaning of locus is nothing but the moment that point B follows after rotation. So this was the first position of point B. This is the second position of point P. So this is the moment or of point B. So it is in engineering drawing terms, it is called as the locus of point B. So how to obtain B1 dash point? You simply have to project this B1 point over here. So this point will be termed as B1 dash point. So this point is termed as B1 dash point. So how to locate the theta? So theta is angle of true length with horizontal plane. So for that we have to locate the true length first. So how to locate the true length? Again go back to the same problem, that from A dash to B1 dash it was the true length. So similarly here from A dash to B1 dash it will give you the true length of the line. So this is the true length of the line. So what is theta? It is inclination of true length with horizontal plane. So basically this angle will be termed as theta. So you have to measure the angle. So this is theta degree, inclination of true length with horizontal plane. So we have found out the true length in front view, we have found out the theta. So how to find out phi and true length in top view? The true length in front view will be same as true length in top view. So how to find out true length in top view? For that you simply have to rotate. You simply have to rotate the front view. So it will be over here. This entire length is rotated. That is from A dash to B dash. Keeping A dash at the center, this will be rotated. That is, rotation means you are making it parallel to xy. So this point we will name this as B2 dash. This point we will name this as B2 dash. We have already used the B1 dash point naming convention. That's why you are using here B2 dash just to differentiate between these 2 points. But the process will remain same. You are rotating the front view or top view. So I am rotating the front view over here. Then you are projecting it downwards. So now next is you have to project it downwards. But up to that, which point you have to project? So here is what you have done. You have projected up to the horizontal level of B. So for that you have to draw a horizontal line from point B, indicating the locus of point B. So this is termed as locus of point B. That is the moment of point B if you rotate the point B in front view. The corresponding moment will lie in horizontal line. So how to locate B2 dash? You will simply project this B2 dash point straight downward. So intersection of this locus of point B and this vertical projection will give you point B2. You will get the B2 point in this way. So how to mark the true length in top view then? So again go back to the same problem. After rotation and projection, the true length was A to B1. This was giving you the true length. Similarly in this case you have to join A to B2. So you will get the true length in top view. You have to check whether the true length in front view and top view is the same. If it is the same, you have followed the correct method. But if the true lengths are different, then might be there is some error or you have followed some wrong method. Then how to find out phi? Just simply this angle will be termed as phi, that is inclination of the true length of the line with the vertical plane. So this is the way how to solve this problem. There is one more term which we will name here. So if you extend this projection of A dash, which is the starting point of front view or top view, and if you extend the projection of B or B dash, this is the ending point of front view or top view. So distance between these 2 points is termed as distance between end projectors. It is termed as distance between end projectors. That is, this is the starting point, this is ending point. So between these 2 projectors, your front view and top view will be there. So again we will revise a complete diagram. You have to remember this diagram as just like a circuit diagram. If you remember this diagram, you can solve any problem of projection of lines. So let us revise. The front view, the angle made by the front view of the line with xy line is indicated by alpha, and angle made by the true length of the line with HP is called as theta. So remember one thing, your alpha will always be above XY line and your theta will also be above XY line. So this is angle made by front view with XY. This is angle made by the true length with HP. Similarly, in top view, beta is the angle made by the top view with XY, and phi is the angle made by the true length with vertical plane. This you have to remember. Other points you have to remember is you can only rotate front view or top view. You can never rotate the true lengths. You can simply project the true length. That is this. You have projected this true length. You have projected this true length. And you have rotated the top view. That is front view or top view. So these points you have to remember for solving any problem of projection of lines. Thank you very much. So now we will see what is the locus of a point. So locus is nothing but a path traced or followed by a point. If we consider the example of projection of lines, so if we take the condition that your line is only inclined to one plane, that is horizontal plane, so this is A dash, B dash representing the front view, and you are drawing it corresponding top view. So it is a line in parallel to VP and inclined to HP. So this is nothing but alpha. Now what is the locus? Now locus is path followed by a point, path or traced by a point. So let us shift this B dash point from B dash to here. So you have shifted B dash from this to point this. Let us term this point as B1 dash, and to trace the same point in top view is simply project and extend. So this point is nothing but B1. So if you shift point B from here to here, what is the effect of shifting this point in top view? So B point oscillates in horizontal straight line. That is, B is shifted from here to here in straight line. Again, if you shift this B dash point from here to here, forming a semicircle, so and name this point as B2 dash, what we observe, this B2 dash, if you project it below, so you will get this point here as B2. So if you shift from B dash to B dash, what will be its effect on top view? So again the B point will be shifted from this to this, again in a horizontal line. So even if you shift this B point over a circle, or in a circular manner, this is A dash and B dash and this is the front view. If you obtain various positions of B point over the circle, so its effect on top view will be in a straight line. So even if you shift this point to here, it will come over here. So this path followed by point B here is a horizontal line. So that horizontal line is called as the trace, is called as the locus of point B. Similarly, here horizontal movement of this point B is called as locus of point B. That is the movement, or sorry, that is the path followed by or traced by point P. So this is nothing but the locus of a point. Thank you very much.